All right, so MAC 248 production procedures, the 16th Thursday. Today we finished up chapter 12. I had you read from 198 to the end of the chapter, and we went over in class for about a half an hour the nuts and bolts of Six Sigma, Poka yoke, quality systems, and charts used for analysis. All right, and then we did the highlights of the entire chapter, which are up here on the board behind me. I assigned homework to read chapter 14 next. It's on lean supply chains. Then we will hand out a take-home quiz next Tuesday, the 21st, and it'll be due on the 28th. So in chapter 12, what was it really about? At a high level, it was about formally instituted quality systems. We learned in the goal that one company trying to save their jobs came up with a system all on their own, and it became that book, and it led on to a movement at other companies to apply similar methods to improve quality, to improve profitability, to reduce unnecessary cost and all those kinds of things. And they became formal quality systems. They evolved into, or they evolved from total quality management, which was invented by Deming. That led to the Six Sigma movement that's around us now. And then the International Standards Organization, 9000, ISO 9000, is a system of documenting everything in your quality system. It's a standard to follow for having continuous improvement and project management. Formal project management and continuous improvement systems are what this chapter was about. These systems, they use a process approach. And I promised everybody today I wasn't going to throw any more 5-step processes at them. But I also thought that this would be a good way to organize your paper, which is going to be a process analysis and then improvements from that. Define, measure, analyze, improve, and control is Six Sigma. Initiate, plan, execute, measure, and control, and close is the project management life cycles. And then this one is the theory of constraints. Identify, exploit, subordinate, elevate, and repeat. All these systems use these kinds of things, and they ask their companies to document their processes and how they're using them, and everything that comes up as a result of them as well. I talked a lot about how at GE they go to great lengths to get small incremental improvements in the interior engine temperature, for instance. The hotter the interior temperature is in in today's jet engines, which can exceed the melting point of the metal, the more efficient the fuel burns, the more miles they get on the airplane flight. The other thing they're always trying to do, Mr. Austin pointed out, is they're always trying to reduce the weight. So they will go to great lengths to reduce the weight of something by just a couple of tenths. Very small incremental improvements in weight are still a big deal on an airplane. So he said they won't budge on any of their tolerances, because if they let it get a little bit bigger, it adds a little bit more weight to the plane, and that's a no-no. So small incremental improvements are the way to go, just like they were in the goal. The other highlights for the chapter was, if you see Lean Six Sigma or lean manufacturing, all you've got to remember is that it's going to be using just-in-time concepts. Just-in-time means that we have almost just the material we need to cut for the day. We have only the amount of machines necessary for the production that we need for the day. And then when the parts are all done, they immediately leave on trucks. They don't go to warehouses and wait. Everything is just in time. Well, that can be a two-edged sword and can really burn you if there are any disruptions. So lean manufacturing does not strictly mean just in time. It means they use those kinds of concepts. So it's going to be important for you to differentiate that. I want you to be able to define and describe the Six Sigma system. I want to know, I want to see that you understand those 3.4 million defects per, 3.4 defects per million units, or how that opportunities to make a defect number is used. I want you to know that Deming was the father of modern total quality management, but he also had a lot of interesting things to say about the cost of quality. He said there was no cost of quality. There was cost of no. Well, anyway, it's in the book. Look in that table. There are 6 dimensions of quality. All of them are very interesting, but the most important one was perceived quality. Companies will go to great lengths to keep the perception of the quality of their good at where it is. That's their top concern, because that is what the customer thinks of you. And if your customer thinks that there's a lot of quality in your product, your customer will gladly pay more, and almost to the point of wanting it to be almost exclusive. And perceived quality is the father of the fat profit margin. So that's why it's such a big deal. Poka-yoke means mistake proofing. You learned that in jigs and fixtures. ISO 9000 is just a system of documentation of all this stuff. It documents that you have a quality system, and it shows that you meet the standards, and that your company is now, excuse me, your company is now one of the in crowd. You can be part of a cartel, if you will. And if you don't have ISO 9001, you might not get the big long-term contracts. So, over here I described the difference between defects and deviations. Mr. Lowe asked a very good question about how defects are an incident. They are like a gouge left on the face of one of our parts. It kills the part. That was an incident on one part. These charts, flow charts, Pareto charts, and fishbone charts, help us isolate where defects are coming from. Deviations, however, are like on that runtime chart. In our process, we want to minimize the deviations of the entire process. And I use the example of a dulling tool. That when the tool starts to get dull, the part will get bigger and bigger, like on a lathe part, for instance, until it's out of tolerance. Then we change the tool, and we might undercut a couple of them until it comes back into that band. Well, we want to decrease that deviation, and we look at Poka-yoke and other kind of methods, simple methods to make sure that we can get in there. So that was chapter 12. Chapter 14 is next. There will be no class next Thursday. I will give a take-home quiz, and I expect it to be done by the following Monday, which is the 28th. Thank you. Have a good weekend.